Hello everyone, in today's video I will discuss how to import general cross sections in SCIA, especially some complex sections that are not available into the predefined library that is given by SCIA. So if I open the libraries of the cross sections and go under new cross section, you can already see that there is a good library of cross sections that can be used in SCIA. Also you have additional the thin wall geometric cross sections, but if you cannot find your sections in any of the groups, then you can go with the general cross section. If I open the general editor, I will maximize this. You can see that there is a possibility to import a DXF/DVG file in SCIA, and this is what I'm going to present today. So I will open my AutoCAD file. I have already prepared two sections that I will use for my structure. I will first start by creating a DXF file out of this DVG file. So I will go DXF out. Then on desktop I am going to save it under version 2013. Save. Go back to SCIA, to the editor, and then click on import DXF DVG. I will select the DXF, and under general section I will open the file. Keep it in mind that all the layers that you're using should be ticked selected. Also the entity types selected, so you can see all the lines that you have into the file. I will first start with selection mode polygons, as it is already set by default. So the polygons that I will use, let's start with the one on the left, so with this cross section. For polygons I will select this outline, and next I will have to select the openings. Go into polygonal openings, click on this polyline, this one and this one. Then I go to import selected. The polygon will have a material, let's choose aluminium, and the alloy will be the following. Then I click OK. About the openings, I will leave it like it is on default, and then click OK. So now I have my cross section already in SCIA. All I have to do is to assign where I'm going to import it, and I will work in 0, 0 coordinate system. Click enter, and then I go escape, escape, and I'm finished with the section. Let's zoom in. So now I have the section ready into the editor, and I will click close. It will take me to the menu where I can see the properties of the section, and right now I have selected 2D FEM analysis. Then I will click OK. This 2D FEM analysis will take some time, some small amount of time to read and import properly the cross section. I will click close, and I have the general cross section in SCIA. I will close it. Let's select all the elements that will have this cross section. So the elements are selected. Under cross section you can already see that I don't have any cross section assigned, so let's choose the correct one. This is the one. I will go in top view just to see if it's positioned correctly, but it isn't, so I will simply rotate by 90 degrees. Escape. Let's go back to the front view and let's zoom out. So you can see that the section is already imported in SCIA and positioned as it should. Let's work now with the rest of the elements. Let's select the rest of the elements, so this. And instead of going to the library, I will now use cross-section and manage next to cross-section. So I will click on manage. I will go to new, general. I already have my DXF file ready, so let's go to import, choose DXF, and I will switch on general section. So now I have selection mode polygons, so I just click the outline that I want to be a polygon. I will go to the openings and then select the polyline that is going to be the opening. Keep it in mind that I don't use the keyboard right now, I just simply click and then I click import selected. For the material, I want to use the aluminium again, but I will leave it as steel and I will show you how to change it later after you have already imported the section. So I will click OK. For the openings, I will leave it on default, OK. And now I have to assign the center of the section. So let's go with 0, 0, enter, and then escape, escape. Let's zoom in, and this is the cross section already imported and ready to be used in SCIA. But it's partially ready because the material is wrong. So what do I have to do? Let's go back, select the polygon, and you can see here there is a material of S235. You can simply change it here. So I will choose the aluminum alloy that I want to use, and it's the following, yes, and escape, and then I click close. You can, if you want, optional, you can write some name, and then I will click close, but I will leave it as general section. So now I have my cross section ready to be used. But again, if you let's say change your mind again about the material, then you don't have to open the editor anymore. You can change the material simply in here under parameters, material. I will click OK. So let's wait for the 2D FEM analysis. It's finished. I will close this and I will click OK. And now I have my elements all ready into the model. Let's see the positioning of the elements. No, this one is also incorrect. So I will also rotate by 90 degrees and my structure is ready. So now all that's left is to do a calculation. Let's check if it's possible. So let's see if I have already some supports. Yes, I do have the supports and the load cases. I do have the self-weight load case, which is enough. I will click on calculate and we have one load case. Let's calculate it. You can see that the calculation went real fast, although we are using some complex polygonal shapes. I will open the 3D deformations just to see the deformed shape of the structure under self-weight, and you can see that the analysis is finished and we have some results which were pretty quick, shown by the software. So this is the correct way how to import a general polygonal cross-section in SCIA. But it's not always that easy. There are some common mistakes that can be done when importing the section, and I will try to cover some of them. So let's go back to my DVG file. This is the DVG file, and let's try it other ways. So if I start by creating the XF file out of this DVG, let's leave it under 2018 version just to see what happens. So I will save it and then I will click save yes. I will go to the library, cross sections, then I choose new cross section. I'm working with general, and I will try to import the latest DXF. I get an error message, and the error message says that invalid file version. Why is that? The 2018 version of AutoCAD is not compatible with SCIA, so what is necessary is to do the DXF file at least in 2013 version. So never use the 2018 version. Another common mistake is the following. So let's say instead of creating the DXF file, I'm going to save this file into DXF. Let's choose something, let's say 2010 version of DXF, and I will click save. So right now I'm working in a correct version. Save, replace, yes. I will go into my SCIA file. I'm already in the editor, and I will try to import the same file in SCIA. So DXF, click on it, and again I get another error message. It says cannot open file. Why is that? If I go back to my AutoCAD file, you can see that the DXF file is already running in AutoCAD. So if a file is already running in another program, you cannot import it in SCIA. I will close this file and let's work with another file. So a solution for the previous problem is if I close this file, then the DXF now it's closed. If I go back to my, to the DVG, then if I open the general sections, now you can see the file is okay and can be used in SCIA. But let's try to import another section. If you see this cross-section, looks like a normal cross-section and looks like it can be imported in SCIA. I will try with the DXF out, and I will do it the correct way. So I will choose a correct version. Let's go with 2010 version, save it. I am working in DVG, so the DXF it's already closed in the background, and I will go to SCIA, try to import it. I will open DXFs. This is the newest DXF, and you can see that the representation of the lines is not correct in SCIA. So there is a problem between SCIA and AutoCAD. And why is that? I will go back to the AutoCAD file just to see. So it looks like a normal sections with lines, but in reality this is not the case, because if I select one of the lines, I will click, just right click somewhere on the background, you can see that this is not a polyline, but it's an spline. Splines are not compatible with SCIA, so a solution for this problem is to convert this spline into polyline. So I will click convert to polyline, and we will have to choose a precision. What I prefer is to use the smallest degrees possible, so I will go with 1. In this way, the less nodes will be created and the cross-section will be less complex for exporting SCIA. Again, I selected the other spline. I will click on the spline, try to convert it into polyline. Again, I'm using 1, enter, and now if I select, you can see that the circles became squares. So this is not a spline anymore, but it is converted to polyline. So let's try it again. DXF out, create the DXF file. I will save it under version of 2010. Save it, yes, save. Then I will go back to the SCIA. I will close this, import. Then I will use the DXF file. Let's click on this, and you can see that now I can import this section. I have the selection mode under polygons. Okay, let's try this one more time. So I will select this outline as polygon, not using the keyboard. Again, I'm going to polygonal openings. This is going to be the opening. Import selected. Let's work the aluminium. This is the correct aluminium. Yes, for the openings I leave it by default, and then endpoints will be 0, 0, enter, escape, escape. Another important thing to know is that my AutoCAD is set to millimeters, and the editor in SCIA is also set to millimeters. So I work with sections in millimeters. So I'm finished with this section. I'm going to close it, and I will click OK. Now that I have more nodes than normally, the 2D FEM analysis will take a bit more time compared to the other sections that I already imported, but again, it's imported, close, and you can see it looks normal, and this section can also be used if needed into the model. So this is all I have prepared for the general polygonal sections, and apart from the polygons and their openings, there is another cross-section. There is another type of cross-section that can be imported into the general section editor in SCIA. If I go under new, you can see that I also have the thin wall geometric sections, but the library of the thin wall section, the geometric shapes are somewhat limited. So if you don't see your cross-section in here, don't worry about it. You can simply draw it in AutoCAD and with the general import it in SCIA. So I will go back to my AutoCAD. I have prepared two shapes for the thin wall sections. What do you have to do is always to put the axis or the central line of the section, and this way you can import it in SCIA. What I prefer is always to join all the lines into one polyline. This way it will be better for import in SCIA. So now I have this in polyline. I will simply click DXF out just to create the DXF file out of this DVG. I will work in version 2013. Let's go save, and then I will go back to my SCIA file, import DXF DVG, the DXF file, and you have the thin wall section here. So the selection mode is under polygons. If I try to select, nothing cannot be selected just because I don't have polygons. What is polygon for SCIA? A closed polyline can be considered a polygon. So because I don't have closed polylines, there are no polygons to be selected. I will switch to thin wall. Now I have all the lines active, and I will select this polyline. Keep it in mind it's in millimeters. I will click import selected. I will work with steel S235. Okay, and for the center I will choose 0, enter. So I will zoom in. It's already very thick. I will lower to, let's say, 4 millimeters, escape, and I'm finished with this thin wall section. I will click close, and you can already see that the cross section will be created. Let's do another general cross section. Another way of doing a thin walled cross section, if you prefer, you have the option in here, thin walled. If it's somewhat more simpler cross section, you can click on the thin walled, click OK, and you can either start by clicking on the background just to draw the shape, or you can do it with coordinates. Let's do something with coordinates, like an example, -125, 50, -125, 0, then 125, 0, 125, 50. Then I click escape, escape. I can also change the thickness of this. So in example, if 20 millimeters is too much, let's go with 6 millimeters in example. Let's zoom in. So, and this is the shape that I draw in the editor from thin walled. You can also import section from the library. So if I click import section from a library, you can choose some of these sections and work extra on it, add some parts with the thin walled. Then I will click close. Now I have it ready. I will click OK, and I will close it. So now I have also this ready. You can see that the shape type is thin walled compared to the previous that were thick walled. What is the difference between thin walled and thick walled? While the thick walled cannot be classified by the software, the thin walled sections already have some straight lines that can be classified by the software. So after you do some calculations and you try to do steel check or aluminium check, you can get the classification, the correct classification done by the software. And you can work with either of these sections that you need. So that's all that I've prepared for today. Thank you for watching my video.